What I want to have a look at today, as the slide suggests, is the role of manipulatives in maths education, the what, the when, and maybe the why. That's the plan of where we're going. I always tend to over-prepare, so we'll see how much we get through. I just want to briefly touch on the research. I think it's important always to challenge what we do. So I'm going to challenge whether we should use manipulatives or not. Okay, just to set the scene. Look for a model that suggests if we are going to use manipulatives, which ones might be the best to use and where. I'll have a little activity for you guys to do around some common manipulatives. I'll show you two websites that contain digital manipulatives that I think are very useful for you to use. And then if we get a chance, we'll look at one or two iPad apps. There's an opportunity, if you like going forward, if you're interested in iPad apps, to see the research that I'm doing. Okay, so I based this slide on a meta-analysis of 55 articles in the literature about manipulatives. So if ever you're short of reading material, a meta-analysis is a good place to start, because it means an academic has done the work for you. So in this case, these academics looked at 55 case studies and they compared in these case studies, or they looked for groups that used concrete objects in the literature, concrete objects, manipulatives, maths materials such as these, versus control groups of students who only used maths symbols. And the good news is, for those of us using manipulatives, is that they found a small to medium positive effect. All right? So yes, it is good to use manipulatives, but they found a few riders. Okay, now the strengths of the effects, in other words, some manipulatives have a medium positive effect, some only had a minor effect, depended on the perceptual richness of the object. By perceptual richness, they mean how much an object relates back to something in the real world. So that would be a perceptually rich manipulative. All right, that would be, these ones here would be sort of somewhere in between. So the coloured cubes and our MAB blocks would be bland in terms of richness. Now, the interesting thing though, depending on the age of the child, sometimes the perceptually rich ones cause problems. Okay, because, oh, here's this bear, oh, hello. Okay, so they'll be playing, but apart from that, when we're looking at creating sets and looking at cardinality, they have trouble disassociating that that's a bear. Okay, so we might find that we introduce concepts with perceptually rich things, but some researchers found that the bland ones, so a tub of counters, is much more useful for a range of activities. So if you can have a little kit on your student's desk that they use all the time, the novelty of playing with them goes away, and they can actually use them for representations. Obviously, your role as the teacher, the level of guidance, and then the developmental level of the user. So if we think back to Piaget, pre-operational, F year 1, concrete operational year 2 to year 6A, formal year 7 on. The strongest effect was in that concrete operational. So that's good news for us. That's the age of kids that we're dealing with. Okay, so the takeaway message from the literature: with your support, appropriate materials, student learning is enhanced. All right, so we've confirmed what we thought we knew. Manipulatives, good. Okay, now we have to decide what manipulatives to use and when we might use them. So we can look at another model. When I went to Teachers College, that shows how old I am. Some of you went to university, would have come across Brunner's work. All right, so it suggested that kids learn by doing, then representing that doing with pictures and diagrams, and then symbolic representation. Okay, Dale built on that work and looked at, there's the 3 stages there: enactive, iconic, symbolic. And there's the sorts of activities. It's a little bit dated, the research. We'll update that in a moment. that might be considered enactive, what might be considered iconic and symbolic. All right, so what I have done with this model is develop it into something that we might be able to have a look at in terms of maths materials. So we can see just by looking at the diagram that most of our work, our strong base, is down here in the inactive area, and we've got different materials that we can use. Some work in the iconic, and eventually, as Peter said, we want children to be operating symbolically, which is a shortcut for the work that they've understood. All right, our tendency can be in primary schools to let's go straight here and get a lot of work done. Okay, kids might be able to do it, they might not, they won't have a strong conceptual base. So some points to note there. We're tracking from the concrete to the abstract. We need to consider carefully student learning stages when selecting materials. So if we're introducing a new concept, we might be working here. If we're practicing a concept, we might be working here. And here, that might be where we're doing our reinforcing work. Right? So we need to carefully consider when we use different materials. Now, materials often have an intended use as well as ancillary uses. So I'll show you in a moment how we can use some of these manipulatives in ways that maybe you've used, maybe it's some learning for you. The important message though is that we have to be careful that sometimes materials can develop a weak concept or they can actually be harmful. So an obvious example, and one that you wouldn't do, but to make the point, there would be no point using the base 5 MAB blocks for decimal work. Okay, that would be inappropriate. So we need to just be careful when we're using our materials to work them through an active stage, an iconic stage, and a symbolic stage. So I'll just play with my materials here for a moment with algebraic thinking. So what might be the concept that we want to get kids to understand in terms of algebraic thinking? If we go right to its nub. So we certainly have procedures, we have algebraic procedures that we want them to be able to do, but what's the notion of algebra, do you think? Pattern. Okay, so yes, it definitely works on patterns. Okay, so we look at what's happening, we can extend patterns, we can build on patterns, yes. If you think of the equal sign, what's the equivalence? Yep, so what's equivalence? Balance. Okay, so really when we're looking at an algebraic expression, we're looking at balance. We can look at imbalance as well, but traditionally more in primary school we look at balance. And that notion, if we do something to one side, we might need to do it to the other. So if we're looking at algebra, we might use a balance scale. So we can put in an unknown if we like. Okay, and then we've got our bears. So we can have a couple of bears there, and we can have a couple of bears there. And sometimes you have to cheat a little bit as a teacher. It's very hard to get it balanced. Okay, so we've got a balanced relationship there. So if I'm adding bears, I can add one each side and they'll stay balanced. I can remove, 3 bears from each side, 2 bears, 3 bears, and it will remain roughly balanced. And then we can start working out, if we like, the unknowns. So we can start with that concept that the equal sign is a sign of balance. It's not a sign of total. All right? Kids will see that equals means total because that's all they've been exposed to. Equals doesn't mean total. Equal indicates what's on one side of the equation is equivalent on the other side. Then we might go to something a little bit more sophisticated. I really love these little balance scales. So we've used, if you like, some familiar objects. Okay, now we want to be using some substituted objects, some maths objects. And again, when we do it with the kids, we could initially have them seeing the numbers and getting that notion. Okay, so if I have a 6 on this side, I can have a 2 and a 4 over here, and it will be nicely balanced. And we can play around a lot with that, just to get that notion of balance. All right. Now, to make it a little bit more conceptually challenging for the kids, I can do something similar with you and swing it round here, and I'll set up something over here. Okay, move my little bucket out of the road. And I'll establish something over here. All right, so what we've got with this scenario is some unknowns. All right, we've got two unknowns here and an unknown amount here is balancing with this amount over here. So if I remove 2 from this side, okay, obviously I need to remove 2 from this side, okay? So now I've got 2 lots of these equals the total there, and I can flip that round and you can see that the unknown was a 4, okay? By the way, these are also very good for the concept of mean, okay, which is also a levelling. All right, so there we've used a substitute. Whoa. There we've used substituted objects. Let's have a look at a digital object. Okay, hopefully it's remembered these websites. Okay, we can come to a digital object such as this. Okay, now where this is different to the iconic stage is that kids are active with this. So they can actually start moving. Okay, well, I've got to build my story first. So I've got 2 of those and 3 of the ones. Okay, you get the idea, and they'll build the 9. Okay, so effectively that is this. Okay, beauty of these is that I've only got 1 of these. If we had a bank of laptops or whatever, kids could be using those. Okay, so that's the digital manipulatives at an active stage. Where were we? Current slide. Okay, and then we would start looking at the iconic, and we could use materials such as these. Okay, so it's not going to move, but they can still be building. That one is less abstract than that one. Okay, so that's at that iconic stage. And then finally, if I had a visualizer, we'd be looking at the symbolic. By the way, they've done a lot of research where if you have 3 add 4 equals box add 2, what do you think a lot of kids put in the box? 7. Okay, because they know equals 3 and 4. Okay, the smarter ones in a sense put 9. Okay, but they haven't got that notion that equals means balance. Okay, what I want you to do now, I want you to do a little bit of work. All right, so here's some common resources that you'll use in a maths classroom. MAB, tape measures, tens frames, you might have seen those, quite handy. Obviously work with counters, a feely bag, okay, or your favourite resource. So what I want you to have a quick chat, you'll only have a couple of minutes, come up with whether and how you think the materials are useful in creating conceptual knowledge, and where some misconceptions might come if you use them at the incorrect stage. Okay, so think of your favourite resource, what concepts have you used it for, and you think outside the box. So you might have used some MAB in some really interesting ways. Okay, conceptually, not to stand on to reach things and stuff like that. So conceptually rich ways that you might be able to share. Okay, so spend a couple of minutes chatting about that. Okay, any stories about how you've used one of those? Or let's take the MAB, they're a common maths material. How have you used them? Have you noticed any problems that kids have had? Or can you think of where it might be inappropriate to use MAB? So obviously they're a place value resource. Okay, what are some problems maybe that can be caused by using MAB if we use them a little bit too early? And are there alternatives that we might use? Obviously the problem with these is a child's quite entitled to say, how many blocks am I holding up? And they'll say 1, Mr. Larkin. 10. No, it's 10. No, it's 1, I'm pretty sure. Okay, and particularly when they get obviously to the hundreds and the thousands. Okay, I've seen MAB used for decimal work. You've got the same problem, okay? Now kids, we're going to pretend that this is a 1. So you might be doing this in year 4, something like that, year 4, year 5. It's 1,000. Well, it's not 1,000, but you know what I mean. So we have to be careful what concept that we're showing kids, and we want to keep consistency with our materials. So I suggest to the kids, I wouldn't do it because I'd cut a finger off, but you might have someone handy in school that the first time maybe you try to slice one of these up. Okay, or I didn't bring paddle pop sticks. You could bring a paddle pop stick along. They're used to seeing that as 1s. Okay, so we just want to make sure that we're using our resources really well for conceptual development. What about our feely bags? How can these be? They're a bit of a risky name, I know. I don't know what the politically appropriate name is. Put your hand in the bag. Our bag that can contain lots of things. Maybe we'll call it that. How could we use something like this? Okay, around what, Sue? You think?
Around shape and smooth and soft. And
Yep. So in the early years, they can be getting their maths language, their attributes of shapes. Okay, certainly probability, statistics, that sort of stuff. Okay. Yep. So again, we just want to make sure that we wouldn't be using that initially and saying what's the probability of, picking out a colour when they're in grade 2 and all they need to know is impossible, certain, might happen, might not. Okay, so just be aware, I'm a big fan of using materials, but you can, as sort of Peter indicated with the graphics, we can actually be doing kids a disservice sometimes if we're not giving them proper materials. All right, so what about digital manipulatives? All right, such as the one I showed with the algebra scales. There hasn't been as much research done because they're reasonably new. But again, meta-analysis has suggested that virtual manipulatives allow a different type of exploration than you can do with pen and paper. So the beauty of the digital manipulatives is that you can reset them. All right, so they can do something with a digital manipulative, reset, do something else, reset. Each time you'd have to be using a piece of paper. If you've got enough ICT in the school, then individuals can be working on their own, they're in control. I'm suggesting to you that they're best utilised after or at least alongside concrete manipulatives. So don't be in a rush to get the stuff up on the interactive whiteboard. All right, it's very abstract. It's effectively an icon. Okay, get them using the materials. I won't have time to go through these 2 websites thoroughly with you, but I'll show you on the next 2 slides. They're 2 quality websites, and again the presentation will be available for you, so you don't need to be writing down the URLs. I believe EQ schools now can search through Scootle. All right, so Scootle's a great portal to all things manipulatives. These are 2 good ones. The BBC has a lot of good stuff, so does the ABC. Okay, the nice thing about Scootle though, obviously, is that it matches the Australian curriculum. So you can go in there and search for manipulatives that might be appropriate for statistics in year 2. Okay, and it'll bring back, and you can fine-tune your search for learning objects. All right, the 2 that I recommend for you are both from the States, so they suffer from...
feet and inches.
Yep, there's that, Imperial.
Dimes and quarters.
Yep, that they certainly do that, and also they don't match up our curriculum exactly, but a good teacher, we're all good teachers, we can easily take something from there and make those adjustments. All right, so there's a couple of samples I've provided there for you to have a look at. This site though is sorted on those 5 topics, so they match pretty well with what we're doing. Number and algebra there, geometry, measurement, data analysis, probability, and they're sorted in year levels, so pre-K to 2 for our early years, middle years, upper primary. So that's quite a nice one. It's out of the one of the universities, I think Utah, in the United States. Here's the other one I recommend. Illuminations. When you visit Illuminations, you'll need to click on the Interactives tab, and then you can do a nice search. Again on year level, again on topic. Now, the nice thing about Illuminations, they're a little bit ahead of the game in comparison to the NLVM, in that they're starting to make theirs run on Android devices, iPads. So if you're in an iPad school or an Android school, the NLVM are Flash-based or Java-based, sorry, so they won't run on your iPads. But there's some for you to have a play around with. Okay, in the last 5 minutes, I just want to have a look at 2 apps. And when we're looking at these 2 apps, I want you to be thinking about whether they're enactive, iconic or symbolic, because that'll give you a clue when you might use them, and the type of knowledge that they develop. So by conceptual knowledge, that's what we've been doing today. Procedural knowledge is knowing that area of a rectangle is based by height or length by width. Declarative knowledge is that fluency. So good knowledge of tables, for instance. So I'll show you 2. I recently, or last year or so, reviewed 142, and I'll provide the link to that. So if you're looking for apps, if you're in a school that uses apps quite a bit, I'll see if this works. Let's see how we go. I'm going to try to plug in my iPad now. So here's one called the area of figures. When I reviewed this one, it was just the area of rectangles, and so they've added parallelograms, triangles, circles. I'm really sad. The students laugh when I talk about this. Circles are out of primary school. We don't do, according to the national curriculum, you don't do circumference, area of circles anymore. You used to do circumference in year 7, area went to year 8. So from next year, if you're a circle lover, either get yourself an advanced class or move to high school. Yeah, I believe they're looking for good people. Okay, so we'll have a look at the area of rectangles. So this one you can see already that it's going to be enactive, okay? Because kids can be doing some manipulating. There's going to be some procedural knowledge. This one has some tests, and then there's a challenge. So if we have a quick look at the manipulative, okay, we can start. It's been a while since I've played this. All right, let's see if we can fill our rectangle. So we can add a square, and we can start looking at what might comprise area. Okay, so they can see that it links nicely to multiplication. They can get their row, they can get their column. All right. In the practice one, if we go back home. Went back where I was. In the challenge one, they get to, I think they can even manipulate their size of their rectangle. Okay, so this one I would consider a really good app. Okay, because the kids are involved. Okay, so they can be inactive. Once they're comfortable with that enacting of the resources, they can come back and do some more what we might we might consider a lesson, and there's actually a talking lesson there for them. Okay. The other one I want to show you, just by way of comparison. Stop. By way of comparison is this one. Also an area app. Okay, now unfortunately you'll have to turn your head on the side. It doesn't orientate, but you can see that this one is more a series of lessons. Okay, so there's no way for the students to enact with this. All right, they're passive. They're just being told basically a formula. All right. I asked the students at uni, it's quite interesting, when I ask them what's their concept of area, and they'll go length by width. Okay, so that's, I don't know how it happens, but that's their concept of area. They've got no notion that it's a covering. Okay, so when we're looking for these apps, have those things in mind that I've spoken about, whether they develop conceptual knowledge, procedural knowledge, or declarative knowledge. Okay. if you're interested, that's the summary of the research that I've done. It's been published in the Australian Primary Maths Classroom Journal. I'm not sure whether libraries subscribe to journals anymore. You can get this one online. It is very good for primary school teachers. The articles are about 2,000, I'm not saying you can't read, don't hear that, but they're about 2,000 words long, and they're very much practice orientated. But they're based around research. So someone's done something and found something. So if you're looking for a maths journal, that's quite a good one. So I classified them against a few different criteria. I won't bore you with the details. I also mapped them against the Australian curriculum and rated them tier 1 to tier 4. So area of rectangles, that was that first one I showed you. It came in the top 10. If you're interested in the full list, and again I'll make sure this is available for you on the TAG website, if you click on that link there, it'll take you to a review of 142 apps. So if you're looking to use apps with your classroom, I've done a lot of the donkey work for you, because you can waste days. And just by way of a short message, the descriptions on the iTunes store are less than hopeless. All right, it's just someone flogging their app. Okay, so at the very least, if you're interested in apps, I've critiqued them against the Australian curriculum and also on the type of knowledge. So takeaway message, and the message I give students: use the manipulatives. The pre-service teachers are always in a huge rush to get things done. So they'll do their half-hour lesson for me, and they've taught the whole year content descriptor in half an hour. All right, less is more in primary maths. If we get the concepts right, the upper primary, secondary teachers will be very helpful. Okay, so it's a matter of, if you're in the early years, that you try to avoid saying equals means total, because then someone like me spend most of my time in upper primary. No, Mrs. Jones in year 2. Okay, so you've got to unteach. So it's just being aware of making sure we get the concepts right.